Hi, my name's Scott Irwin of Purist Fuel Technologies. About 3 years ago we started developing a method for cleaning gasoline direct inject engines. And a few of the things that we looked at when we were developing the system was, first of all, we couldn't find a single cleaner, a solvent that would do a good job as far as releasing all the deposits in the intake. So we came up with is a system where we use two different cleaners. One's a surfactant, one's a solvent. And we compare it to washing your hands. A surfactant is a soap. You would put soap on your hands, a lot of soap, then you'd use water, a solvent, to wash it away, then you put more soap and more solvent, and you'd wash it away. We call that cleaner scripting for our system. And it is more effective not just to use two cleaners, but to actually script the use of the two cleaners. So instead of just using all of one cleaner till it's done and then following it up all of the second cleaner, the interaction of the two cleaners together makes it more effective. One of the other things that we found was the conditions within the engine itself makes cleaning more effective. So if you take any hot surface and you take any cool liquid and you put the cool liquid onto a hot surface, you get thermal shock. Thermal shock will fracture a lot of the deposits that are on the surfaces, gives you more surface area once it's fractured to work, and obviously it makes it easier for the system to work. So how we accomplish that is this machine has a couple different modes where you can either spray for 30 seconds, shut off for 10, spray for 20 seconds, shut off for 10. The main purpose of the 10-second with no spray is to allow temperature in the intake to reestablish itself. So when you hit it with the next spray of liquid, now you've got a thermal shock again. The second benefit of pulsing the cleaner into the engine is that one of the risks of doing an induction cleaning is that you're putting liquid where the air is supposed to be. So if the engine's not breathing in the liquid at the same rate that the machine's putting it in, you get puddling. Puddling creates the opportunity, the risk for hydrolock. So if a bunch of liquid puddles and then gets put into a cylinder, you'll get a non-compressible liquid on top of a piston. The piston would then come in contact with the head and cause damage to the engine. So one of the other features that we put into the machine to prevent hydrolock is a vacuum switch, what we call HydroSafe. So this hose would connect to any vacuum source on the engine. There's a vacuum switch here. If the vehicle stalls, it ceases to generate vacuum. That shuts off the machine. So if the technician's not there and the car stalls, the machine won't continue to spray liquid into a dead cylinder. The machine's also programmed in the middle of the service to do a 1 minute pause. So again, for a full minute, just have airflow through to dry up any potential puddling that's happening in the engine. One of the other aspects of making induction cleaning more effective is how you deliver it in. A lot of companies just use a spray nozzle that they position before a throttle plate and they spray. And the problem with that is that the spray rarely is efficient enough to go around the throttle plate, so the liquid impacts the plate, slides to the bottom, is no longer airborne and atomized, and is not going to reach all of the cylinders effectively. What we developed was an induction adapter. This will fit onto any vacuum source. You match up a hose with the size of the vacuum port, and this has a small aspirator in it so that we can spray within a vacuum. One of the features that we designed into the system on our service hoses is a section that the technician can see through. So the technician is able to visually see if there's flow of cleaner through from the machine into the engine. Okay, so one of the features of the machine is it is air driven by shop air. This is a regulator to set the air pressure. The spray nozzles are designed for 60 psi as the most effective atomization for the spray nozzles. So that's where we start. The air pressure determines how much liquid is going into the engine each minute. So if the engine was choking too much at 60 psi, we could dial the pressure back to 50 or 40, and we'd be putting in 1/5 or a third less product for each minute. Also, if it's not choking at all at 60 psi, we could increase the pressure to 65 or 70 and then increase the amount of liquid we're going in to the point where it does slightly choke the engine. You want to saturate the deposits on the valves, and so if it's not choking it at all, it's probably an indication that we're not getting enough cleaner there fast enough. So increasing the air pressure would make the service more effective, and also would take less time for the technician. So the same machine can be used for both induction cleaning and fuel rail. Just by selecting on the service mode button, you can switch from induction mode to a fuel rail mode. Be different cleaners that we would use, but the same machine and a different service hose. Same machine could be used to do a fuel rail service or an induction service.